Hello and welcome to the shop and another installment of Shit Gets Fixed. And this is the part where I like to remind you that here at Shit Gets Fixed, we use your likes and subscribes to offset the financial burden for people fighting cancer. And the best part is, it's completely free for you to be part of this kick-ass approach to philanthropy. You can learn more about how we make this all happen at our nonprofit website, www.shitgetsfixed.org. Well, alrighty, let's get after the shit we need to fix. Every once in a while, interesting and sometimes not so interesting fabrication, machining, or welding jobs of all sorts of shapes and sizes find their way to the shop. And I always hear the same thing from each and every client. They always say, no one else will do it. So either I'm crazy for taking these jobs that no one else will, or I'm just incredibly skilled and talented. You be the judge. Well, you didn't have to be so mean about it. Anyway, one of these interesting jobs came into the shop a couple days ago, and it's this. This is called a Harp Light, and yes, it is rather large, and yes, it is made out of cast iron, and yes, it is heavy AF. This light was brought to me by a very prominent light fixture company here in town, and we partner up on projects from time to time. They make beautiful light fixtures of all types, sconces and chandeliers and whatnot. They didn't make this particular light, but because they do a lot of custom one-off stuff, the person who owns this light sent it to them to get some shit fixed on it. And then the lighting fixture company brought it to us to actually do the fixing shit part. And it's not so much we need to fix some shit on this light, but more we need to make and modify shit to get this light to do what the customer wants it to do. So that's the backstory. Anywho-ha, the person who owns this light wants to mount it to a custom cut piece of stone quarried special for this project. And the problem is our Harp Light doesn't currently have a proper base to make this happen. So our job is to make a proper base and modify the light so it will live symbiotically with the new base that we make. Well, let's do this. So the plan is to take this. This is a 15-inch by 15-inch piece of 3/4-inch A36 plate steel and turn it into our base. And yes, that piece of plate steel is heavy AF. Now, for starters, this is a very low tolerance spec job. Let me explain what I mean by this. A tolerance spec is typically called out by the customer. Let's say the customer wants us to drill a hole in a particular spot. They want us to be dead nuts on that spot, but are going to give us this acceptable plus or minus tolerance. You could think of it as wiggle room, and this job has plenty of it. Normally here at the shop, we see machining jobs that have a tolerance spec of, let's say, plus or minus 0.005 of an inch. And that's a little thicker than a piece of paper. So in that case, the customer wants us to drill that hole in the exact spot they specified, but will allow us to be just off that exact spot by the thickness of that piece of paper. And when you start to think about that, it's nothing short of incredible that we can even do this. And that spec is for general production stuff, and it's pretty easy to fall within that spec. Now, for more precision jobs, we might see a tolerance spec of plus or minus 0.02 of an inch. That's half as thick as that piece of paper, and that's a pretty tight spec for manual machines like we have here at the shop. Now, if we were making this base for a Harp Light that was to be installed at, oh, I don't know, let's say the International Space Station, NASA could call for a machining tolerance spec of 0.002 of an inch. That's 0.0002. To put that into perspective, that's taking the thickness of that piece of paper, slicing it into 25 equal slices, and one of those slices is about 0.2 of a thou thick. That's the NASA spec we're talking about. It's absolutely mind-blowing and basically impossible for us to achieve here at the shop at any level of consistency. Even the slightest change in room temperature could throw us off that spec. To demonstrate this fuss about tight tolerances, you might have noticed I've been holding on to this. This is my 0 to 1 inch micrometer, and it has the ability to show us measurements down to the 4th digit. So down to that NASA spec we were just talking about. Now, I'm holding onto it by the barrel, which is something you wouldn't commonly do, but go with me here on this. Now, before I started yapping on about all this tolerance stuff, I had the micrometer zeroed out. And now that I've been holding onto it for a bit here, let's see what has happened. If you look closely, the micrometer no longer reads 0. If you compare the two lines 4-0, that's the one over here on the sleeve, and the other one over here on the thimble, you can see that they no longer line up. And that's our 0 mark. But if you look around here at the vernier scale, you can see the two lines for 1/10,000th of an inch do line up. And this has happened simply because I've transferred some of my body heat to the barrel of the tool, and it has grown slightly in size. And that's just the measuring tool itself getting close to NASA's plus or minus spec limit. Compound that with our machining equipment and the part itself changing shape as they heat up during the machining process, and you can see how difficult it is to achieve these high levels of tolerances. But lucky for us, we're not making this base for NASA. And I realize I've gone off on one heck of a tangent here. But nevertheless, this metrology stuff is very, very fascinating. Anyway, let's get back to our base. So I've laid out the features we need on our base, and before I did any of that, I removed the mill scale from our piece of plate steel. What is mill scale? Well, first and foremost, it's a big pain in the ass. But to be a little more scientific about it, it's actually a massive pain in the ass. Mill scale is a tenacious, bluish-black coating of iron oxides that forms on the surface of steel when it cools after being heated and rolled at high temperatures. And our A36 plate steel has been heated and rolled at high temperatures. You need to remove mill scale, or you should, before welding or painting, because it makes for an unfriendly environment if you don't. And mill scale can be difficult AF to remove, and in this particular case, it was. Common methods to overcome this almost impossible task of mill scale removal include grinding, sandblasting, and even chemical processes. So let me walk you through what we got going on here. In the center, we will drill a large 2.5-inch hole for the electrical connections to pass through. The next 4 holes out from center will be drilled and tapped for 1/2 by 13 stainless steel threaded studs, and some corresponding holes will be drilled in the current base of the light for those studs to pass through. Some stainless steel cap nuts and special washers that we need to make will hold the light to the new base, and I'll get back to those special washers in just a second. At each corner, we will drill a 3/4 inch hole that will be used by some sort of concrete anchor to mount the whole kit and caboodle to that custom piece of stone. Now back to those special washers. The top side of the base of the light has this angle or non-linear curve to it. I've made this cardboard cutout so you can better pick up what I'm throwing down here. One side of our special washers will be profiled for that angle or non-linear curve, and the other will be flat. Now, as we go along here, we have a few what I'm going to call intermediate steps, and all of those steps relate to drilling those corresponding holes in the current base of the light. You see, we need those holes to be in the right spot, not only so our threaded studs will pass through those holes, but also so the light will be centered and square on our new base. Anyway, I'll explain more about those intermediate steps once we get there. I have our new base, or what will be our new base, clamped down to the welding table. And we're going to get things started by drilling those 3/4 inch holes at the corners of our new base. And to do that, we're going to use this. This is a mag drill. For those of you that don't know what a mag drill is, firstly, it's a fantastic piece of kit. And in addition to being fantastic, it's basically a portable drill press with an electromagnet at its base. So you can stick it magnetically to ferromagnetic materials and drill reasonably accurate holes. All right, let's fire up the mag drill. To drill the large hole at the center and the 4 holes for those threaded studs, I've moved our operation over to the vertical subtractive manufacturing department. And I know what you're thinking. Why didn't we just drill all these holes with that fantastic piece of kit called the mag drill? Well, the center hole is too big for the mag drill, and those holes we need for the threaded studs need to be drilled to 27/64ths, and I don't have a mag drill bit that size. In addition to those things, being able to utilize the milling machine's DRO or digital readout will come in useful after those upcoming intermediate steps mentioned earlier. We are at the point of those intermediate steps, and you might have noticed I didn't tap or thread the 4 holes for those threaded studs. That's because we're going to use our nearly completed base for a fixture to help us drill those corresponding holes we need in the current base of the light. Let me walk you through the plan. We are going to place the base/fixture onto the base of the light. You can see I have the light turned upside down. Then we will use a transfer punch to indicate or transfer the position of those holes from the new base to the light. But before we can do any of that, we need to get the new base centered and squared. To get us centered, I've made this. This is a centering pin, and we will use it to line up the large hole in the center of the light with the large hole in the center of our new base. To get us square, we will turn the new base like a steering wheel in a car until it is parallel with a line that will be projected from the front-facing window at the top of the light. To hold our new base tightly in position as we do our work, I've made this yoke or collar. We will use this and the threaded ends of our eye bolts to sandwich the new base and collar together, pinching the light and holding our new base in position. Next, we will remove our centering pin and move or shuffle our new base so that the large hole at the center is over the first of the 4 holes we need to drill. Lock it in place again with our collar, use the mag drill to drill our hole, rinse and repeat for the other 3, and I know this is a long list to follow, but hopefully it'll all make sense in the end. To finish up the work on the new base, I've moved us back to the vertical subtractive manufacturing department and placed the new base back in the same position it was before, or re-indexed it, by using a vise stop and some alignment pins on the milling machine's fixture plate. This allows us to utilize the DRO, or digital readout, to return the spindle of the milling machine directly over the same position of the holes we drilled previously. This way we can use a spring-loaded tapping guide to make sure we tap our 1/2 by 13 holes as close to 90 degrees to the new base as possible. So now our Harp Light has a proper base for it to be mounted to that custom piece of stone. And I know you're wondering about those special washers. Well, they turned out to be relatively straightforward. After looking at things a little more closely, I noticed that the non-linear curve part of the base started beyond the land area of the washers. So that simplified things, because now we only needed to figure out the proper angle to cut that side of the washers to, which turned out to be 7 degrees. So I set up the Portaband Pro bandsaw to 7 degrees, cut our washers out of some stainless steel tubing. Voila! And this is the part where I always say, job done! The name of this episode is Let There Be Light. And of course, it's because of the Harp Light we just worked on back at the shop. But the title also reminds me of a person I had the pleasure to meet during my cancer journey. And that's why I'm standing here. Because over my shoulder is my local cancer center. And inside of those walls are a whole bunch of very special people that worked extremely hard to save my life, to give me a second chance. And I am so incredibly grateful to each and every one of them. But one of those people really stands out, and her name is Veronica. Veronica works on the 3rd floor, up there, at the check-in desk at what is called the day hospital. The day hospital is where you go to get chemotherapy, and trust me, it is not a place you want to go visit if you don't have to. Anyway, every time I would go to the day hospital and get checked in, Veronica would greet me with a big, incredible smile, would always remember my name and say it was good to see me and that I looked wonderful. She has this way about her. You see, this is the part that I was reminded of by the title of this episode. It's because of how Veronica goes above and beyond just doing her job. She offers a little bit of light, a ray of hope, along that very dark journey called cancer. And I saw her do this for so many cancer patients that stepped foot in that day hospital. Veronica's light didn't just reach me, but it reaches so many people. So, I dedicate this episode to her and to all the other healthcare workers that go above and beyond their job and offer that light, that ray of hope for cancer patients everywhere. You see, those selfless acts of compassion, that light that has shined so brightly during the darkest days of my life, is something I will never forget. So let there be light. Anyway, I appreciate you watching, and we'll see you next time.